Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring equivalent ratios. Now, in previous lesson, we have been using tables to represent equivalent ratios. In today's lesson, we'll be using a double number line. So in example 1, it says the ratio of the number of boys to the number of girls in a choir is 5 to 4. So here we have a double number line. We have the number of boys is going to be modeled on the top number line, and the number of girls will be modeled on the bottom number line. So of course, if there's 0 boys, there's 0 girls, and then the ratio told us for every 5 boys, there are 4 girls. So what they want us to do is show the possibilities for the number of girls and the number of boys. So what we're going to do is we're going to generate a list of equivalent ratios. For example, if we scale by 2, 5 times 2 is 10, and 4 times 2 is 8. 10 to 8 is an equivalent ratio to 5 to 4, because if we multiplied them by 2, we would get 10 to 8. Now, we could also triple it. 5 times 3 is 15, 4 times 3 is 12. So 15 to 12 is also an equivalent ratio. Now, hopefully you can see that the top number line is scaled by 5s and the bottom number line is scaled by 4s. So we can just continue this pattern. 15, 20, 25, 30, 35, 40, and 45. On the bottom, we have 4, 8, 12. We can continue to scale up 4 every time. 16, 20, 24, 28, 32, and 36. Now, once we have a bunch of equivalent ratios, we can use those equivalent ratios to answer questions. So in problem B, it says, for each of the following, the number of girls has been given. Give the number of boys that are in the choir for the different number of girls. So let's say there were 12 girls. Let me highlight that. The corresponding value for boys would be 15. So when there are 12 girls, there are 15 boys. All right, what about when there are 28 girls? Well, I'll find 28 on my double number line, and the corresponding number of boys would be 35. Now, what if there are 60 girls? What I want you to notice that on our double number line, the number of girls only goes up to 36, but they're asking us about 60. So what I want to do is look at all the possibilities for girls and find one that would be easy to scale to 60. So right away, I notice this 20, because I can scale 20 up to 60 pretty easy, because 20 times 3 is 60. So now I've got another entry, another equivalent ratio. Now, if I did that to the 20, I'm going to have to do the same thing to 25. I'm also going to scale this 25 up, and 25 times 3 is 75. So now I know when there's 60 girls, there are 75 boys. So 75 to 60 is an equivalent ratio. All right. In problem C, they want to know, would the ratio 80 to 64 be equivalent to the ratios above? Well, I'm not sure. Let's look at our top row. Is there a number in the top row that would be easy to scale to 80? There's actually a couple numbers in there that are pretty easy to scale to 80, but I'm just going to go ahead and use, let me highlight it here. I'm going to use this 40 because it's pretty easy for me to scale a 40 to 80 if I multiply it by 2. So if I double 40, I get 80. But that means I'm going to have to do the same thing to the 32. So I must also scale this 32 up by 2. So if I double 32, I get 64. So the question was 80 to 64 an equivalent ratio? And the answer was yes, it was an equivalent ratio. All right, example 2. A house painter mixed 5 gallons of blue paint for every 9 gallons of yellow paint in order to make a green paint. Complete the double number line to find other equivalent ratios. So in this number line, our top number line is going to represent the number of gallons of blue paint. Our bottom number line will represent the number of gallons of yellow paint. So of course, we have 0 blue, we have 0 yellow. But then it told us if you have 5, for every 5 blue, you need 9 gallons of yellow to make this green paint. So if I scaled this up to find equivalent ratios, I could double it. If I double 5, I get 10. If I double 9, I get 18. I could triple it. If I triple 5, 5 times 3 is 15. 9 times 3 is 27. But I hope you see that you're going to have multiples of 5 on the top row and multiples of 9 on the bottom row. So this would be 20, 25, 30, 35, 40, 45. And on the bottom, let's see, 9 times 4 would be 36. 9 times 5, 45. 9 times 6, 54. 9 times 7, 63. 9 times 8, 72. And 9 times 9, 81. So there's our multiples of 9. Question A says, which ratio of gallons of blue paint to yellow paint will make the same shade of green paint? The first ratio is 27 to 15. Well, 27 is not a multiple of 5, so I'm going to get rid of that. Okay. How about 40 to 72? Yep, that was in our chart. 10 to 45. Well, we have a 10, but this is not a 45, so I'm going to say no on answer C. 30 to 54. So that is in our chart. So 30 to 54 and 40 to 72 were the equivalent ratios. All right. Problem B. If 80 gallons of blue paint is used, how many gallons of yellow paint will be needed? Pause the video and try this problem on your own. All right, welcome back. So what I did is I looked in my chart at the number of blue gallons, and I looked for a number that would be easy to scale to 80. So I used the 40. And I said, if I were to double the 40, I would get 80. So what would happen if I double the 72? Well, that would give me 144. So 144 gallons. All right, example 4. At a store, the ratio of the number of limes sold to the number of lemons sold is 2 to 3. Complete the table to show the relationship between the number of limes sold and the number of lemons sold. Now, in this table, they've given you some values, but you're missing some. So what I'm going to do is I'm going to add the simplest ratio to the top, 2 to 3. And what we're going to do is create equivalent ratios by scaling up. So to get from 2 to 24, you would have to multiply by 12, which means I'd have to multiply this 3 times 12. So 3 times 12 would give me 36. So when there's 24 limes, there must be 36 lemons. All right. So the next blank gives me the number of lemons is 63. So I'm trying to get from 3 to 63. So what I need to know is what am I scaling by? What's my scale factor? So I'm going to take 63 and divide it by 3. So 3 goes into 6 2 times, 3 goes into 3 1 time. So that means my scale factor here is 21. So I must take this 2 and multiply it by 21. And 21 times 2 is 42. All right. Now, in my last one, I have the number of limes is 72. Pause the video and try to find the number of lemons if there are 72 limes. When you're finished, press play and check your solution. All right, welcome back. So I wanted to see, what did I scale by to get from 2 to 72? So 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. Bring down the 2. 2 goes into 12 6 times. So I'm scaling by 36. So I must scale the other side by 36. So I'm going to take 36 times 3. That'd be 18. 3 times 3 is 9, plus 1 is, so 108 lemons. All right, example 5. Tyler earns $165 for every 20 hours he works. If he works for 40 hours, how much would he earn? All right, now let's set up this double number line. This time it's not labeled for you, so we're going to have to make our labels. So we are comparing his earnings to his number of hours. So this is always 0, 0. And we know that he earns $165 for every 20 hours. So if he works 40 hours, we want to know what would his earnings be. So all we have to do is figure out what we scaled by. So to get from 20 to 40, hopefully you can see that you had to scale that by 2. So if I scaled the bottom number line by 2, I must scale the top number line by 2. So 165 times 2, 12, 13, 1. That would give us $330. That's what he earns for 40 hours. All right. Problem 6. A bread recipe calls for a flour to water ratio of 10 to 7. If 500 grams of flour is used in the recipe, how many grams of water would need to be added? All right, so let's start by setting up our double number line. We are comparing flour to water. This is always 0, 0. And they gave us the ratio of flour to water was 10 to 7. Then the question says, if 500 grams of flour is used, how many grams of water would we need? So I know the amount of flour is 50. We do not know the amount of water. So what we have to do is figure out, what did we scale by to jump from 10 to 500? So to find that out, I'm just going to take 500 and divide it by 10. So 10 goes into 50 5 times. 5 times 10 is 50. Bring down the 0. 10 goes into 0, 0 times. So we scaled the top by 50. So if I scaled the top by 50, I must scale the bottom by 50. So 50 times 7 would be 350 grams of water. All right, example 7. A recipe for a hummingbird food uses 3/4 cup of sugar for every 3 cups of water. How much sugar would be needed for 9 cups of water? So in this problem, we're comparing the amount of sugar to the amount of water. We know this is 0, 0. And it says we need 3/4 of a cup for every 3 cups of water. And we want to know how much sugar would be needed for 9 cups of water. So we must figure out what we're scaling by. All right, so hopefully you can see that we're scaling by 3. So we're going to multiply 3 times 3/4. So 3 over 4 times 3 over 1, that's equivalent to 3, equals 9 over 4. Now I'm going to write this as a mixed number. So 4 goes into 9 2 times. 2 times 4 is 8. Subtract, and there's your remainder. So this would be 2 1/4 cup of sugar. 2 1/4 cup of sugar. And that concludes today's lesson, equivalent ratios.